Second part is related to the atomic size and atomic ionic radius, and the first question is very simple. He says which diagram represents the change in ionic radius of elements across the third period. We know that when we move across the period, size of the atom decreases, but I'm talking about the atom. These are not atoms, these are ions. So we discussed in our previous question, I think, that the atoms, they have larger size than their cations, or cations have smaller size than their parent atom, whereas anions form larger size than their parent atom. So if we go for that, C will be the right choice. Okay, next, so we have argon, potassium ion and calcium ion. These are again isoelectronic, have the same number of electrons. So in what order do their radii increases? As we again discussed, if we are talking about the period, okay, so across the period size is decreasing, but when we talk about the charge particle, the positive charge particle have smaller size than there. So argon is in the third period, but potassium and calcium both are in the fourth period. So what we can say, the size of the calcium is smaller than the potassium. The size of the calcium is smaller because calcium is the second member in second group, and potassium is in the first. Okay, so the size of the calcium ion is smaller than the potassium, which is smaller than the argon, which is smaller than the argon, because argon stays in the same period without losing or gaining electron, whereas the potassium ion is formed by the loss of electrons. So its one electronic shell is totally lost. So the smallest will be calcium, smallest will be calcium, and then because we left it's only one choice with the calcium starting, so this will be the right answer. Then he says which species has the largest radius. We discussed that the largest radius is phosphide ion, because ions, negative charge ions, have larger radius than their parent atom, and that is further decreases across the period. So phosphide ion has the largest one. Next question, he says which group of particles is in order of increasing size. So order of increasing size, nitrogen, oxygen, fluorine, they are all moving across the period, and across the period size decreases. Nitrogen, oxygen, fluoride, so again they are moving across the period size decreases, although they are negatively charged. But remember, nitride ion has the larger than the oxide ion, which is larger than the fluoride ion. Again decrease, we will observe decrease, and he is asking for the increase. Okay, then sodium ion, magnesium ion, aluminium, again we are moving across the period size decreases if they are from the same category, like the cation or anion. But here if you say one is positive, one is neutral, mean the neon is noble gas, and then fluoride. So the size of the fluoride is here, whereas neon stays here, but the size of the sodium is far more lesser because of the cation. So cation formed by the loss of complete valence shell electron, whereas same electron is added into same valence shell, so the size increases. So this will be our right choice. Okay, so the graph is like this, mean we are moving across the period. So argon is here, the fluoride ion has greater size than the argon, and then argon, finally the sodium ion is smallest. Okay, so smallest, this is the increasing order, so D will be our right choice. Question 14, use of the data booklet, again mean we have to use the periodic table. And although this question is related to the first ionization energy, but you can relate it to the size. And remember that larger the size, it will be more easier to remove electron, and we discussed exactly the same phenomena here. Okay, so if you can see easily if you can replace the element, Sodium is from the group 1, so here francium is from the group 1. Okay, this is group 1 as sodium. The radium, okay, so radium is in group 2. And radon is the noble gas, like neon. Okay, so remember, the size of the neon in all of these is smallest, so it will be way difficult to remove the electron from radon, so it should be the last one. So we have two choices with the last radon here, and the size of the francium among all is the larger one, so it will be way easier to remove electron from the francium, so it should be first one. So accordingly A will be our right choice. So no need to worried about the endo or exo, most endo or less endo. Just focus on how much energy they need to remove. Okay, so which will be the francium will be the most radio, so we can say least endothermic, and the radon will be most endothermic. Moving on, this question again I think we discussed it during the lesson as well. So this says that how do atomic radii and ionic radii of these elements compared? Magnesium is a metal and it's ion. When cations are formed, their size is always smaller than their parent atom. So this and this will be the right choice, but not this and this. Why? Because here it says size of the magnesium is smaller than the magnesium ion, which is wrong. Size of the magnesium atom is bigger than its parent. Size of the magnesium atom is bigger than its ion. Whereas when the anions are formed, they gain electron and their size increases as compared to their parent atom. So sulfur atom has smaller size than its sulfide ion. So B will be the right choice. And guys, next question is exactly the same but with the different element only. Instead of the magnesium, now we have sodium. So size of the sodium atom is bigger than the sulfur. Why? Because across the period size is decreasing, so sodium has greater size than the sulfur. So we can say this and this could be correct, but not this and not this one. Furthermore, ions. Sodium ion is formed by the complete loss of electronic shell, whereas sulfur doesn't. So it means the size of the sodium is smaller than the sulfur. So D will be our best or correct choice. Then next question, again same question as we discussed in earlier. So group 1, size of the group 1 atom will be smaller because they are changing into, like this is the same question we already discussed with the exact same option, but the different style of the question. So smallest will be sodium, then it will be neon, and then fluorine, because of the gain of electron. So this will be our right choice. Next, and I think is the last question. Again same style, same question, but with different elements: neon, sodium and magnesium. Sodium and magnesium are both in the same period, okay, but not the neon. So F, you can see across the period size is decreasing. So magnesium has smaller size than sodium, and then neon has the smaller size, bigger size than the sodium ion. Why? Because neon is in the second period, okay, and is not involved in losing or gaining electrons. So its electronic shells are the same with equal distribution of electrons. So it should be the right answer should be the smallest is magnesium, then sodium. That choice we have only here. If you ignore the neon, still you can easily answer. Okay, if you just focus on magnesium and sodium, you can easily answer. No need to focus for the neon. So these are the questions, guys, and please remember when I was solving the question, I just checked, there was a difference or there is a mistake in this marking scheme. No need to focus the sheet which I gave to you. Please focus the answer sheet over here, okay, or just go through the discussion which we done in this video. So I hope you get better idea. You do have to solve this worksheet by your own. If you still have questions, you can discuss with me with personal or sending message, is up to you. And if you need any assistance, you can contact me. Okay, you can contact me easily anytime. Take care of yourself. We'll see you inshallah next video. Take care and see you soon.